All right. Scatter plots, line of fit, statistics. I love statistics. Let's go. Okay, so first we're going to talk about scatter plots. Scatter plots are when there's just a bunch of dots, usually from a bunch of data that was collected, and they have three different correlations. They can either go up and down, which is a positive slope. You could have a negative correlation, which would have a negative slope, or you could have no correlation. And we've seen these before, but the thing you haven't seen is this line on here, and we're going to talk about that line here today. So the line of fit is the line that describes the trend of the data. So once you have a line of fit, then you can write an equation for that line. So here's the data. Here is the line of fit. Here's the line of fit, and there would be no line of fit when there's no correlation. So that's what you're going for. And then we're going to try to find that equation today. The best line fit is usually a graphical method, and usually you punch all the data in a calculator, and the calculator will give you the best line fit. I don't think we're going to have to deal with that today, but that's what that is. Linear interpolation, otherwise known as linear extrapolation, used to predict values outside of the range. So we already talked about this. If I had a bunch of dots going like this, and I used a line like this, they'd want to know what about a dot out here. All right, so determine whether this graph shows positive correlation, negative correlation, or no correlation. If there's a positive or negative one, describe it. So you're going to have to describe how x is related to y. So graph shows the average number of students, how many students, and per computer for each year. So the answer is there's a negative correlation because it's going down. With each year, the more computers are at Maria's school, so making the students per computer rate smaller. Pause this, give it a shot. Okay, positive, negative correlation or none, and then describe it. So definitely positive. Let's see, we have year and number of prescriptions, so as the year goes up, or as the year increases, the number of prescriptions goes up. Wow, that is scary. So A. All right, population. This table shows the world's population growth rate. So in the 1600s, there were 500 millions, 100 millions, 200 million, 400 million, 640 million. Draw a scatter plot to determine what relationship, if any, exists in this data. Let the independent variable be the year, so that would be x, and the dependent variable be y, which is population. And they just graphed the chart that we had there a little bit ago. The scatter plot seems to indicate that the year increases, the population increases, so there's a positive correlation between years and population because they're generally going upward. So we're going to draw a line of best fit. Now you have to be careful on this. You don't just want to draw, the line that's best fit would actually go through like here. Okay, it kind of goes in between all of them, but we don't want that line. We want the line of fit so we need data enough to be able to make an equation. So you need to draw a line that passes close to the points. So no one line goes through it, and they actually picked one that looks like it goes through this point, and this point is the one that's closest that they could actually get the data of. So using slope-intercept form, write an equation for the line of fit using the 2 points that they picked, which would be these 2 points. So first we need to find the slope. So we'll punch that into our slope formula. And we'll simplify that out. So approximately 35.1. So using that slope and then using whichever of the 2 points, which was this one and this one, whichever of those points we can use on the data to choose. And they chose 850. So putting it into point slope form, take the points, put them in. So they put this one here, and 35.1 went here. Put all those in. We're going to distribute it over. And then make y by itself by putting that to the other side. And that gives us Note this number. There's what our number comes out to. Slope-intercept form, we could take y equals mx plus b, punch in the numbers that we had, same three numbers, different places, find out what b is, and then we're going to take that number, move it, and put it into our y equals mx plus b. Note that is the exact same equation on both accounts. All right, so we're going to have to walk our way through this one here. So this shows the number of bachelor's degrees in thousands since 1988. So first you need to draw a scatter plot, determine if there's a relationship. Go. All right, looks like it's a positive correlation because it's generally going up between the year and how many things were received. All right, draw a line that best fits that scatter plot. Well, this one's fairly easy. Just look at them. The only one, that one's going down, that one's going straight, that one, don't get confused by that one. That one, they just connected the dots, basically. That's the one that's best fit. Notice again, they put it in between, they picked 2 points that were remotely so they could actually make a line out of it. Write the slope-intercept form of an equation of line best fit. Go. All right, so they picked year 4 and year 10 as their 2 things. So I'm going to make this my y2, y1, x2, x1. Put that into this. So 1184 minus 1136. 10 minus 4. Put those into my calculator. Gives me 48/6. Which gives me a slope of 8 per year. Okay, so, wow, that gives me 2 options. So it looks like we're going for y equals mx plus b. So let's take one of these points. So y is going to be 1136 equals 8 times 4 plus b. 8 times 4 is 32 minus 32. 1104 equals b. So I can just put those there. There's b, there's that. It's going to be a. Oh, sorry, d. There's my 1104. Use the predicted equation of this, which we found earlier, where x is the year and y is the population in millions, to predict the world population in 2010. There's our original equation. We'll replace it with 2010, apparently. And simplify that out. Gives us approximate, then we translate that into millions by adding 6 zeros to it. And that would be our answer. All right, same concept here. Go. All right, so our x is years in 1998. What will happen in 2015? So we need to figure out what that number is. That's where we're going to start on this. So 2015 minus 1998. That would be 7, 1, done. And those will cancel out. Yes, I do subtraction differently. Ask me about that later. I have a really fast way to do that without doing all the borrowing stuff. To predict the number here, so we're going to put 17 in for x. Y equals 8, 17, line there, plus 1104. Punch those into my calculator. Gives me 136 plus 1104 gives me 21240. All right, so for the first time all year, I did it right. I've triple checked my answers. 2015, if 1998 is 0, then 2015, there's 17 years. this is all done correctly. So I think their answer is wrong. If you can figure out how to prove to me their answer is right, I might think about giving you extra credit. Come talk to me in class.